Hello, welcome to a video on the last example of the section 4.2 notes, and also happy Thanksgiving. So we're going to look at example 7 from the section 4.2 notes. It's the last example. I believe it's on page 6. I can't remember how many pages these notes had. But here we're looking at a linear motion problem, and we're given the acceleration, and the acceleration is a constant value. So we can write the acceleration function as just that. Oops, that looks kind of weird. A of t equals 12. So we're asked to find the velocity and position functions, and we're given some other information as well, like when the time is 2 seconds, the velocity is 4 meters per second, when the position, the initial position, which is time is 0, is negative 11 meters from the origin. So if we think carefully about this, we do know that v prime of t equals a of t, and that s prime of t equals v of t. So velocity happens to be the antiderivative of acceleration. So because if the derivative of velocity is acceleration, then the reverse, right? So velocity is the antiderivative of acceleration, right? Because if we're taking derivative velocity to get acceleration going backwards, that's what we need to do. So our velocity function will then be 12t plus a constant. Like we talked about in the notes earlier, when you take an antiderivative, it's kind of like doing the reverse of the power rule. We're going to add 1 to the exponent, divide by the new exponent, and add a constant. Because the derivative of 12t plus c would be 12, right? V prime here is 12, which is basically what acceleration is. But how do we find c? How do we find this? Well, we use that information right there. V of 2 equals 4. So 4 equals 12 times 2 plus c. So c is going to be negative 20. So our velocity function, with all the information that we're provided with, is simply that. Hopefully that makes sense, because the derivative of that would be 12, and if I plug in 2, I do get 4 for my velocity. So everything makes sense. Now to get the position function, position is the antiderivative of velocity. Because the derivative of position was velocity, right? Because velocity is a derivative of position. Position is the antiderivative of velocity. So if I take the antiderivative of velocity, that'll be 6t squared, because the derivative of 6t squared is 12t, minus 20t, and of course, plus c. If I take rid of that, I do get 12t minus 20. Then if I plug in 0, I'm supposed to get negative 11 as my initial position. And so c is simply negative 11. So my position function would be 6t squared minus 20t minus 11. The derivative of that would be 12t minus 20, which is the velocity function. The derivative of 12t minus 20 would be 12, which is the acceleration we're given. And of course, the initial conditions are all satisfied. So hopefully that makes sense. Velocity is 12t minus 20. Position is 6t squared minus 20t minus 11. All right, enjoy the rest of your break, and I'll see you guys on Monday.